Hi everyone, I hope you're doing well. I'm Aliou Zanouri and today I'm going to talk about the thesis in context entitled Traffic uh, Management during the natural disasters, and our case study would be as the uh, main picture is showing you. It would be the case study of the Prince George. Today, I will talk about the research and the details. After that, main submodels and four steps in transportation engineering, analysis of theories, and after that, we will have conclusion. As you know, my research is about traffic management during natural disaster, and case study of Prince George is our case study, and we will do it based on crisis management as well as transportation network management in wildfire and flood hazard conditions. Actually, objective of my research would be investigating the social awareness role in the reduction of the evacuation time and providing a deep understanding about influential factors on evacuation time, developing a multi-scenario transportation-based evacuation plan, as well as actually understanding the behavioral change into the evacuation simulations and analysis of the temporal aspects of the evacuations. And at the end, we will provide a basis, a foundation for future analysis. The plan of the research is here. You can see it has five different steps. First one is literature review, second knowledge analysis, third model preparation, then model run and analysis, and after that publication and defense of the job. The first step, including in literature review, has three main parts. The review on crisis management document, the review on microscopic traffic modeling documents, and the overlap. Uh, I will tell you in more details that's what I mean. Um, we need to review the previous research jobs as we did part of it in our initial steps of the preparation of the proposal and the documents we have. These are super important because bylaws, the frameworks, the other documents by the government, by the United Nations. These are the actually um, the foundation of our job. We don't want to invent the wheel once more, and we are going to actually have a foundation, a solid foundation for our job. These documents provide solid foundation for the job. British Columbia All Hazard Plan is one of them. And the other thing is the statistics. The age distribution graphs, the household size, income distribution, and anything that can help, that can change the disaster management is among these statistics. One question. Do you know how many people are living in Prince George in 2016? It was 74,000 people. In 2021, it was 76.7 thousand people, and with the same rate of growth in 2024, it is estimated as 78.4 thousand people. These are important. How many people are there to evacuate. These are really crucial elements. And after that, we will do the knowledge analysis. Not only we will analyze the statistics, but also we will go for analyzing the structure of the actions, actually the distribution of the tasks, the approaches and key roles, the standard operation procedures, SOPs, emergency operation plans, EOPs, and analysis of the available traffic data, because the topic has two sides. And also the model preparation. This is the heart of my research. Human data, road data, vehicle data should be entered to the PG model, and after that, after sensitivity analysis and after the data gap analysis, we will have a calibrated and verified and validated model. And after that, we can use this model to actually evaluate the actions and the scenarios. And as you can see, this heart of the research, microscopic traffic simulation model preparation, has different steps: preparing the network, preparing the demand data, preparing signal and controls, public transportation, behavior of drivers, policies, and a lot of other data. I will give you two examples based on two parts of the data we need to insert the actually microscopic traffic simulation model. We don't have enough time to go, for example, for the network, to go for signal optimization, actuation, or so on, public transportation. We will talk about just demand data and behavior of drivers. First, let's go to the behavior of drivers. What behaviors do you see here in this picture? Yeah, some cars change the lane, but before changing the lane by these cars, the other cars, the car which changed the lane and the other cars are actually maintaining their speed based on the speed of the car which is in front of them. It is adjustment of the speed based on the traffic speed. After that, changing the lane and selecting the gap between other cars. I told you the name of the models, the sub-models we have for these means. Can anybody remember these models? Yes, possibly based on the fundamentals of traffic simulation book by Barcello. Um, Car following model, lane changing model, and gap acceptance model are the main submodels of the simulation in Ames on Traffic Simulator software. Car following model is really complicated. We try to model it in Excel. It was really complicated, and these are the elements. The main elements are shown here. Uh, it gets some elements, and it gets also the simulation step, and it will give us a velocity of cars and the location of them. I don't want to go through each formula, so I will pass. We have car following, lane changing. This is the logic of the lane changing, and there are a lot of formulas for this, and gap acceptance as well. Uh, I'm going to focus on demand data as well. For demand data, what is the demand data? What do I mean by demand data? The demand of transportation. How many people want to go for example, part A of the network to part B of the network. We have four-step regional travel forecasting model. We call it four-step modeling. And this four-step modeling, including trip generation, trip distribution, mode choice, and trip assignment, as you can see here. What is the trip generation? Imagine the city of Prince George. For example, one part is Hart, one part is downtown, one part is College Heights, and imagine one part is outside of the city. For example, the Old Caribou Highway, for example. Uh, Look at the Hart location. How many people want to have a travel from Hart? This would be trip generation. By trip generation, we mean how many people want to have travel from that location. And how many of these people from here want to go there? How many want to go here in C? How many want to go to the D? These are trip distribution. And how many of people will use their own car? How many of them will use the bus? How many of them possibly walk? This part is mode choice. Who knows what is the OD matrix? Origin destination matrix. Yeah. OD matrix is a matrix like this. For example, we have four places here. This is obviously a simplified model. Here it's kind of example. We don't have just four locations. We will have more than 200 actually centroids. Each of them are a centroid. And from A to, for example, A, we don't have any trip. From A to B, we had 50. From A to C, we had 50. From A to D, we had 100. How many trips are generated in A? Sum of this line, yeah? How many trips is generated in A? Can you tell me? Yeah, 200, yes. Said, yeah. And how many of them will go from A to B to C to D? So, which steps an OD matrix will cover? Step 1 is 1 and 2. And how about the mode choice? We know, for example, from this matrix, for example, 80% use car and 20% use bus. So we will have two different OD matrices. 4 to 4 OD matrix for car, 4 to 4 for the bus. And what is the trip assignment? How much traffic, how much of the traffic goes to which route? For example, there are two routes between A and C. One is from here, two is from here. How many people go in first route? How many people select the second route? And the other thing, how we can understand our assignment is correct, our matrix is correct. Possibly after assignment, we can check it in some points, not in all the points, and make sure how is the actually assignments. And if we go from trip assignment to the trip generation, to actually make the matrix accurate, we can do something which is named matrix adjustment. How we understand the assignment is correct? We will compare it with the real data, isn't it? How? If the x and y are the same, so this assignment, this part of actually, so sorry, traffic assignment was correct. So we did it, and we actually compared the assignment we did based on 2NT centroids and PG traffic network. These are the actually data we got from comparison between the assignment and the real data. As you can see, uh, which one is more accurate? Could you see? Yes, the Frank and Wolf method of the assignment gave us the better results, so we will go for it. And we can use it to make old or inaccurate OD matrix more accurate and to give the more accuracy to the matrix. And we call this process matrix adjustment, and we can do it. Uh, Okay, let's go to the other step of my research. Model run and analysis. This would be this step. The theory of the design experiment can help me with it to do the experimental design and to run the scenarios as well as analysis on outputs. And at the end of the research, I will write and publish the publications, and actually I will prepare EOP and SOPs, and hopefully I will defend. At the end of the day, I'm going to say thank you to all of you. Why is that? Thanks, Zahra, for deep ecology. It's actually it can have indirect effect on my research. Jimmy Ma for feminist political ecology. It will help and the understand of women involvement method in crisis management. So indirectly, it can help me and through game theory. Possibly the game theory can directly use in demand simulation, traffic management, and crisis management. Thanks to Genevieve theory of island uh, biography, indirectly can actually have some effect on wildfire, one of the hazards that I am studying. And thanks to Harry measurement theory, most of the inputs, calibration, verification, validation, and all of the inputs are based on this theory. Uh, Lucas told us metabolic theory of ecology, and it can indirectly change and affect my research. Reza told about resilience theory. The resiliency of the individual can increase the social resiliency during crisis. Hossein told us about selfish gene. It might indirectly help with the wildfire estimations, possibly through the change in the actually um, the plants growth in area around the city. And Sami, disaster risk reduction. The main purpose of my research is the disaster risk reduction, so it is really relevant to my job directly. As Stanley told us about Gaia hypothesis, it might indirectly affect natural disasters. Andrea told us the biophilia hypothesis, and it's also might be helpful, um, might be influential on natural disasters. And Orhan told us about chaos theory, which we see in disaster management and microscopic simulation models. And thanks to myself, to share the theory of plant behavior which can affect car following, lane changing, and gap acceptance, and also the behavior of the people during the disasters. In addition to all of these theories that we mentioned, I tried my best to select all the theories, other directly relevant theories, and collect them here and use them in three main part of the research: literature review, knowledge analysis, and model preparation. I will add the theory of the design of experiments that I needed in model runs. Thank you very much for your attention and have very good night.